All right, I think this will be a little bit better. I don't know if I'm on both or not though. I don't know. I gotta figure it out. But at least I know the YouTube should be good. Let me unpause the TikTok real quick. Okay, I think we should be good now. I think. Um. All right, but I'm gonna keep going. So where were we? Oh, we did number 7. All right, I'm on 8. Oh yeah, this one looks ridiculous. All right, so hold on. Before I do this one, I want to make sure I'm good. Give me 5 seconds. Hold on. I'm gonna pull my stream up on my phone to make sure I'm good. Okay, sweet. Mr. Allman saving us all. I'm trying, man. Okay, I'm back. I don't know if my Twitch is on, but I know for the YouTube I'm good. Okay. So number 8. Let me zoom in just a little tiny bit. Hold on. Because I know this one can get kind of tiny. All right, let's try that. Okay. Now implicit, it's not a y equals. That's how I know that. But I gotta divide or not divide, derive both sides with respect to x. How do I know with respect to x? Because of this right here. So let's do it. Derivative of tangent. And before I derive it, I'm going to notice that my input is a function. So I am going to have to use the chain rule. So derivative of tangent, I know is secant squared. And then that input stays the same, xy. And then I got to multiply by the derivative of xy. Now notice xy is a product of two functions. So I got to use the product rule when doing the chain rule. I got to talk about that for a second because I think that overwhelms some people. Whenever there's multiple rules in one, my advice to that is just whatever. I guess it's easier said than done, but whatever rule applies, just follow that rule, and whatever happens, happens. Dang, Marcelo paused Thursday night football to join the live. Let's go. W Mans. Okay. So I was just saying, whenever there's like multiple derivative rules going on at once, uh, my best advice is to just simply follow the rules. So what I mean is, remember how we were deriving tangent? I know that tangent's derivative is secant squared. And then my input just stays the same. So just xy. But I just noticed that xy is a function or something other than x. So therefore, I have to use the chain rule, which says to multiply by the derivative of my inner function xy. But the thing is, here's where some people can kind of get confused because multiplying by the derivative of the inside requires yet another derivative rule, which is the product rule. So that's what I'm about to do right now. The derivative of the first function times the second function. Let me be consistent and highlight my first and second functions. So x is my first, and I think we do yellow and blue. Y is my second function. So derivative of the first times the second plus the first function times derivative of the second function. Okay, yeah, that's kind of tricky. I'm not gonna lie, I can see some people kind of getting tripped up on that in my experience. Can we get a W from everybody? That'd be kind of clean. I've never got a like a streak of W's in the chat before. That'd be cool. But anyways, okay, so that's the left side equals derivative of x. That's just 1. All right, so this one is honestly a question that I would consider a hard question because once you do the calculus part, everybody knows it's just algebra and you get the dy dx's on one side and all the non-dy dx's on another side. Let's go. But the thing is, you can't just subtract and add stuff like willy-nilly, because everything on the left side is like you can't subtract. How do I explain this? Basically what I'm saying is this secant squared, you got to distribute it so that you can like individualize all of your terms, if that makes sense. So hopefully you can see that you can't just like subtract this one y right here. I got to distribute first. So it's going to be secant squared of xy times y, but I'm going to write it like this just because to me that just looks a little better. Okay, that's my first distribution. I guess I should draw arrows. That is my first arrow. And then here's my second arrow, which is going to be, how do I want to write this? I'll go plus, and then I'll go x secant squared of xy dx, or dy dx equals 1. Okay, appreciate the W's. All right, let's lock in. Okay, so from here, now I feel like I can see that this very first term does not have a dy dx in it. So I'm going to move it to the left side of my equation by subtracting it from both sides. Secant squared of xy. And then I'm going to go minus y secant squared of xy. Hopefully, I'm starting to look like some in my answer choices. Let's see. I don't see any tan, but let me just keep going and see what I get. All right, so now I have x secant squared of xy dy dx equals 1 minus y secant squared of xy. Goodness gracious. Yeah, this one is a little bit of a doozy. Wait, Mathematic Fanatic says, hold up. Let me know if I did something wrong. Okay. From here, I'm just going to divide. I'm just going to divide by x secant squared of xy. Anybody in the chat, if I messed up, let me know. But I'll just keep going and see what happens. So this will be dy dx equals the right side divided by the x secant squared. And let's just see what happens. Hopefully I didn't mess up. I would like to go 18 for 18. X secant squared of xy. Okay. I don't think I can cancel anything out. 1 minus. I think maybe they factored out. It's looking like B. I wonder if they factored something out. Let me see. If I'm pressed for time, I'll go B. But I wonder if they like. Oh, I think I know what they might have did. Actually, I don't know. I wonder if. No, that wouldn't work. I was gonna say I wonder if they like split it up into two fractions and did something like that. Let me. I want to go B, but let me run through it real quick just to see if I messed up, and then I'll just go back over it later. Derivative of tangent is secant squared xy chain rule Derivative of first times the second plus the first times derivative of the second equals 1. Did I distribute correctly? Looks like it. Secant squared of xy dy dx equals 1. Maybe whenever I like rewrote it the way I did, I shouldn't have. Don't distribute, multiply both sides by cosine instead. Oh yeah. I think cuz secant, okay, so hold up. So if I multiply, let me rewrite secant squared, cuz what is that? 1 over cosine squared. And then if I take that and multiply it by a cosine, then that'll just be 1 over cosine, which is secant. Okay, let me try it. Instead of distributing, just multiplying everything by cosine. Okay. Cosine of xy, and then that'll be a cosine of xy on the right. Yeah, this one is kind of tricky, I'm not gonna lie. Okay, here's what I'm gonna do. I'm gonna erase all the work but keep the answer and just see what I get when I do this. That is a good suggestion. Cosine squared of xy. Oh, so then that they cancel out. Okay. Since cosine squared times secant squared should cancel. I see. Yeah, that one is kind of tricky. Here's what I'll do. I'm gonna come back and do this one in its own like individual problem, because this one is hard, and I would rather do like more examples than like take a long time on one question. So I'm gonna asterisk this one. This one is hard. I'm gonna come back to that one, but I think it's B. We'll see. All right, let's go to number 9. Let me zoom back out real quick. Hold on. That was kind of a fun one, I'm not gonna lie. All right, so number 9. We have a graph of f, and then they give us g of x. Hold on, let me zoom in a little bit more so we can see it better. Let me do like, okay. All right, so they give us a graph of f. They give us g of x, which is 2x plus 1, and then h is f of g of x. The question is, what is h prime of 1? Okay. Oh, somebody said D. I'll go back to it. Oh, yeah. It might be. Yeah, it might be D. Yeah, I'll go back to that one before individually though. But all right, let's keep it pushing. So they want h prime of 1. What I'm gonna do first is figure out what is h prime of x, so that I can then just replace x with 1. So if h of x is this, I can derive that using chain rule. So the derivative of that would be f prime of g of x times g prime of x. That's just straight up chain rule. Okay, so from here, I can replace all my x's with 1s. So h prime of 1 equals f prime of g of 1 times g prime of 1. Wait, GPT said E? Bruh. All right, now I really want to I'm excited to go back and do that one. Okay, so from here, let's see. I got to figure out what g of 1 is. I can do that algebraically because they give us g of x. I can use my yellow to find g of 1. And then I can do f prime of that because I have the graph of f. So I'll find g of 1, plug that in, and then g prime of 1. So to do that, I got to find g prime of x. A little bit of a process, but I feel like I see where they're going with this one. So g prime of x would simply just be 2. Okay, that wasn't hard at all. So that means I can actually see some people getting confused here. If they know g prime of x, then g prime of 1. Well, there's no x to replace it with, so it's still just going to be 2. Okay, so now we need to find what? G of 1. I'll do that right here. G of 1. This time I actually have x's to replace with 1. So 2 plus 1 is 3. All right, so here's my updated h prime of 1. I have h prime of 1 equals f prime. This is a good question. F prime of, we said g of 1 was what, 3? Times, and then we said g prime of 1 was 2. Okay. All right, so from here, f prime of 3. Now, I remember on Unit 2 test, a lot of people got cooked on this one, finding f prime from a graph. If you got cooked on this one, that just means we're failing to recognize what a derivative represents. And remember, just derivative just means slope. And so what I think they want us to find is the slope of f whenever x is 3, which is right here. So the slope of that is going to be the slope of this line, which it makes sense why they give us those coordinate points. So I can say f prime of what, 3? That's just the slope between 2 points. I'll go y2 minus y1 over x2 minus x1. So that's what, negative 6 over 4 minus 1 is 3. Negative 6 over 3 is negative 2. Okay, so let's update my h prime of 1. That equals, we said f prime of 3 was negative 2 times 2, which is negative 4, which is an answer choice. I love that problem. That is a good problem. That is a great problem. Shout out to whoever made that problem. Okay, let's keep going. Number 10. Let f be a differentiable function such that f of 3 is 15, f of 6 equals 3. So they're basically giving us a table. F prime of 3 and f prime of 6. Okay? The next sentence says the function g is differentiable and g of x equals f inverse of x for all x. So they're basically telling us f and g are inverses of each other. What is the value of g prime of 3? Classic derivative of inverse problem. Did I watch the Mavs game? I did not. I saw a few clips of yesterday's game. Did they play again tonight? I didn't even watch or look. But okay, so g prime of 3. Remember, whenever you're trying to find prime of a number, find prime of x first. So that way you have something to plug into. Okay, g prime of x. So they give us, let's see. Actually, no, we'll just use the formula for the derivative of an inverse. Flashcards. Okay, let me fix that. Remember, if you're taking the test and you're blanking, what you do if you don't remember this formula is hopefully you do remember that if f and g are inverses of each other, what has to happen is f of g of x has to equal x. That is a fact. So can you suggest a problem? Yeah. DM it to me on, I guess, either TikTok or Instagram so I can see it. Just send me a picture of it and I'll try it. But this right here is just a fact. Whenever two functions are inverses of each other, You can derive both sides and then isolate g prime of x if you forget the formula. But that will take us to what we have here. And then since I have that, I can go ahead and replace x with 3. Hold on, let me move this over a little bit. All right, so g prime of 3 is going to equal 1 over f prime of g of 3. Okay, so next we got to figure out what g of 3 is. And notice that they don't give us g of anything. But we have to use the fact that f and g are inverses. That is what I would consider the hard part about this problem, is that you have to know if, let's see, for g, 3 is my input, so I'm looking for something that has 3 as an output. So I'm looking here. So if f of 6 is 3, I'll draw a little arrow. What that means is that g of 3 must be 6. If f and g are inverses of each other, which they are. Yes, I will put the video on demand up. I had a little bit of a hiccup with some technical difficulties earlier, but one way or the other, I'll put everything up. But all right, so we found out that g of 3 is 6. So I'm just going to update my equation. So this is now 1 over f prime of 6. And fortunately, they tell us what f prime of 6 is. They tell us that it is -2. So -1/2 will be my final answer. That's a good question. Okay. All right, number 11. Yeah, I might as well just do all 18. Might as well. All right, if f of x equals the inverse cosine of x squared, then f prime of x equals what? Okay, this is low-key flashcards, but a little bit of recognizing chain rule. My OG is my x squared. So from here, I'm just going to remember the formula for the derivative of inverse cosine, which is going to be -1 over the square root of 1 minus, not x squared, but my input stays the same. X squared squared. That looks weird, and I can see people missing that. Remember, the formula just says whatever my input is, square it. So my input is x squared, so I'm squaring x squared. But x squared is a function, so I got to use the chain rule and multiply by the derivative of x squared, which is 2x. I low-key have my answer. I'm going to simplify. My numerator looks like it's a -2x, and I actually got blessed because I think that's the only answer choice with a -2x in the numerator. And if I simplify the bottom, I get a 1 minus. If I take x squared and square it, I do get x to the 4th. So that exactly matches up with answer choice B. Not too bad of a question. All right, so number 12, implicit. I want to say this one looks familiar. I want to say I've done this before. But all right, let's try it. So and then again, the reason I know it's implicit differentiation is because it's not an explicit function. An explicit function would be like a y equals some function of x. So because the x's and y's are like intermingled, I got to go implicit. So that means I'm just going to derive every term with respect. Let me laser it. Hold on. With respect to x. That's how I know I'm deriving with respect to x. So my first term's derivative would just be 6x plus, I'll use my handy dandy highlighter, 2xy. I'm going to see that as a 2x times a y. I'm pretty sure I did do this question. And then I'm going to go product rule from here. Derivative of the first is 2. The second function is y plus the first function is 2x. And the derivative of the second function is dy dx. Okay. Plus the derivative of y squared is not 2y. Out of, let's see, I got about 90 people taking this test. My prediction, I say about like, I don't know, maybe 8 or so, 8 to 12 people are going to just say 2y. That's my prediction. But remember, you got to use chain rule and multiply by the derivative of y, which is 2y, which is dy dx, and then I'm going to go equal. Oh, by the way, there is a 1 right here. I'm not forgetting to subtract 1 from the exponent, just so you know. And then the derivative of 1 is 0. All right, so from here, I can just separate my dy dx's from my non-dy dx's. And I can subtract my 2x and my 2y. I mean, subtract my 6x, subtract my 2y from both sides. Like so. And then I'm not going to rewrite it. I'm just going to hope that you see that the remaining two terms both have a dy dx in it so that I can factor out a dy dx. That'll be what? 2x plus 2y. And then that equals negative. Now I bet you they're going to factor. Yep. They're going to factor out a negative sign. So since both of my terms on the right are negative, I can factor out a negative. So that'll be 6x plus 2y. Yes. If I distribute that, I get negative, negative. All right. So my final answer would be, let's see. Ooh, I wonder. It looks like they factored something out. So in my numerator or in my right side, I see that I can factor out a 2. So I wonder if I can do it like this. Because I can factor out a 2 from my denominator as well. So that'll be what? 3x plus y. Yes. And then on bottom, between the 2x and the 2y, I can factor out a 2, so that'll leave me with an x plus y. This is a good example of what I mean when I say if it was an FRQ, we could have been done. But they simplified the answer choices like as much as possible. So not only do we have to like factor a negative out, but we had to like actually factor out a whole GCF. But from here, my 2's cancel. And so I'm left with a negative, and then I got a 3x plus y over a x plus y. Please tell me that's an answer choice. B. Negative 3x plus y over x plus y. Yes. That one's not too bad. I feel like the factoring part or simplifying part of it was the hardest part. Pray for the 8A kids. Is 1A locked? I don't know. Hopefully we're gonna see. It's 15 of y'all in here. I don't know how many of y'all are from 1A, but I don't know. I don't know if y'all are locked in. I guess we'll find out tomorrow. But okay, let's do number 13. If f of x equals x squared minus 4 and g is a differentiable function of x, what is the derivative of f of g of x? Okay, f of g of x, this is ever so loudly screaming chain rule. This is like flashcards chain rule. So the derivative of this will be f prime of g of x times g prime of x. All right. But they give us f of x. So from that, we can figure out f prime of x. But we're going to have to evaluate it at g of x, if that makes sense. Let me find f prime and then I'll show you what I mean. So if we're given f of x, then I can determine that f prime of x must be just simply 2x. So what this means is if I'm evaluating f prime of something, that means I'm just going to copy my f prime function, and whenever I see an x, I'm going to replace it with g of x. That is what I'm going to do. Usually, like in class, if somebody's confused at this point, what I'll do real quick is I'll remind them, like, okay, let's say we're in like middle school, and I tell you that let's use h. Let's say I tell you that h of x equals like x over 2, for example. And then I'll be like, can you give me h of 8? And then y'all learn to do what? Wherever you see an x, replace it with whatever's in parentheses. So it'll look like that. That's essentially what we're doing here. Just on a, I mean, that's literally what we're doing. Whenever I see an x, I'm going to replace it with g of x. So here's what that would look like. That would be equal to, my f prime function is 2x, but I'm going to put a g of x instead of an x. And then I'm going to multiply that by g prime of x. That literally says d. 2g of x times g prime of x. Yeah. That one is like easy and hard. It's like it's easy, but it's hard. I can see some people getting confused on that one. Okay, number 14. In the past, a lot of people have been confused with derivative problems whenever there's a table involved. That's one thing I noticed. 1A and 2A are locked in. All right, let's see. 4B table is locked. Yeah, I don't know about that one. Prove me wrong. Let's go. The question is asking what is h prime of 1. Hopefully you know by now the first thing we want to find is h prime of x. Let me find that first. And I can do that because they give us h of x right here, which again is just simple chain rule, f of g of x. So that is going to be, let's see, f prime of g of x times the derivative of my OG, which is g prime of x. All right, let's see. Okay, from here, what do we do? I got h prime of x. Now I can replace all of my x's with 1s. That's what I'm about to do next. So h prime of 1 equals, I'll go f prime of g of 1 times g prime of 1. I think the rest from here on out I can get from the table, I think. Yes. So f prime of g of 1, well, what is g of 1? G of 1, according to the table, is 3. So this is technically f prime of 3 times g prime of 1, according to the table, is -2. So now the last thing I got to figure out is f prime of 3, which is 7, times -2. Is -14 an answer choice? It is. Let's go. Okay. Not too bad, not too bad. All right. I got what, 4 more? Okay, number 15. This one looks, I don't know. Honestly, if you know your flashcards, this one is not bad at all. It's just an inverse trig function plus another function. You know, you derive one term at a time. And and if you know your flashcards, you can automatically have to pick between 2, because you should know that the derivative of inverse tan is just 1 over 1 plus x squared. Flashcards. It's either D or E. Now I just got to derive 2 root x. So here's what I'm going to write down. I'll say the derivative of, now you can do this a couple of ways. I know some people prefer to rewrite this as x to the 1/2 and then use power rule. You can do that. But I personally prefer to just memorize the derivative of square root of x. And so when I derive, and we were kind of talking about this for a minute today in class, if I'm deriving something with a coefficient like my 2, you can essentially take a shortcut and just carry the 2 over and then just derive the rest. You can do that whenever you have a coefficient. So I'm going to take my 2 and then I'm going to multiply it by the derivative of root x, which I just know from memory is 1 over 2 root x. So just to be clear, this first 2 is on top. This second 2 is on bottom. I should remove the ambiguity and put 2 over 1. Okay. From here, I think the 2's cancel. 2 over 2 cancels out, so I just got 1 over root x, which is in my answer choice. So I'm going to go E. Okay. Couple more. I like this one already. I haven't tried it yet, but just from first glance, I like this one. Hold on. Okay. All right. So for this one, arctan flashcards. Notice there's an OG. I'll even label it. Okay, for anybody not in my class, like what is an OG? We just call the inner function the OG just to give it something to call. But okay, so derivative of arctan is 1 over 1 plus. It usually would be x squared, but instead of x, I have a cosine of x. And if I were to square that, it would be cosine squared of x. But since that is an OG, I got to multiply by its derivative, which is negative sine of x. And then that is my answer. That is literally answer choice A. I don't even have to do anything. That one is actually pretty easy, I'm not gonna lie. Yeah. Okay. 2 more. 17. The table above gives selected values. This is the type of table problem really that a lot of people got messed up on. Whenever there's an inverse involved. Prediction for highest class average. Ooh. Low key, 2B. I'm not gonna lie. I put money on. Well, I'm not actually putting money, but if I had to, I go 2B. 1A and 4B might be that one might be neck and neck. We'll see. I'm excited to see, man. I'm very curious and eager to see how y'all do on this test. Okay, the table above gives values for a differentiable and decreasing function f. If f inverse is the inverse function of f, what is the value of f inverse prime of 2? Okay, what I'm going to do here is, because I'm so used to f and g being inverses of each other, I'm going to write this. Let f inverse of x, I'm going to call it g of x, just for familiarity, just to make it look familiar. I'm going to write it like this. So essentially that means I'm finding g prime of 2. I like it like this because I know the formula. G prime of x equals 1 over f prime of g of x. Hopefully y'all have that formula down by now. Yes, there's an FRQ on this test. Yes. Wait, did I say 2B? I meant 1A and 4B. 2A, not 2B. My bad. I be getting my classes mixed up sometimes. It's a lot of y'all. All right, so from here, since I have g prime of x, I can go ahead and find g prime of 2, which means just replace x's with 2's, and then I can get some stuff from the table. Okay, 1 over f prime of g of 2. Now, here's where people were getting cooked because they couldn't figure out what is g of 2. Yeah, probably. You're right. Hopefully. But okay, so look. It's confusing because they give you no way to directly find g of 2. What you have to do is remember that these two functions are inverses. So for g of 2, if 2 is my input, I'm looking for something on the table to where 2 is an output. And I can see that right here. So according to the table, I know that f of 1 equals 2. I got that from the table. If f and g are inverses, then I know that g of 2 must be 1. That is textbook definition of inverse. Okay, so instead of g of 2, I'm just going to replace it with 1. So I'll say g prime of 2 equals 1 over f prime of 1. That I can get from the table. F prime of 1 is negative 8. So 1 over negative 8 should be my final answer. Let's go. Okay, not bad. I wonder how many hundreds I'm going to get. That's the real question. I feel like I'll get a few. Hopefully more than a few. Last question. Ooh, I like this question. Ooh, I'm glad we're doing this question. Because look, 99% of the time whenever we derive, it's dy dx. But look, this time we're trying to find dy du. All right, let's try it. So we're trying to find, so they give us y equals, but they want us to find the derivative of y with respect to u. What that means is any variable that's not u is to be treated like a function of u, meaning we are going to need to use the chain rule. So I'm going to derive y, but I'm going to do it with respect to u. So the derivative of y with respect to u is dy du. But when I derive x squared, it's not just 2x. Because since I'm deriving with respect to u, that means x is like an OG. So I got to multiply by its derivative with respect to u, which is going to be dx du. That is going to cook a chunk of people. Okay, so that's just the derivative of the first term, and then I'm going to go minus. For this one, my 2 is like a coefficient, so I'm just going to keep it, and then I'm going to multiply by x's derivative, which normally is 1, but in this case, it's dx du. All right, so from here, let's see, what do we do? 2x times dx du. The derivative of x with respect to u. I know we got to use this right here. Now here's the part that I'm confused about, because we have u equals, but we need the derivative of x with respect to u. I wonder if we're supposed to take this equation right here, this u equals 2x plus 1. And then I wonder if I solve for x, then I can take its derivative. Maybe. I don't know. This one's kind of weird. Let's see. I'm going to try that out. I'm just going to see if I can solve for x. I don't even know if that's the preferred way of doing this. So u minus 1 equals 2x, and then I would divide by 2 on both sides. So that leaves me with x equals, I'll go 1/2 parentheses u minus 1. Okay, so that's my x equals, and then from here, I can find dx du, which is the derivative of x with respect to u. So I think I'm going to keep my 1/2 there because it's a coefficient. And then the derivative of u minus 1 with respect to u is technically 1 minus 0. So that's just 1/2. So dx du is 1/2. That is a hard question. I really want to know if there's like a better or more preferred way to do that. But hopefully we get a correct answer. Let's see. Dx du we said was 1/2. Okay, so what is that? The 2's cancel, so I'm just left with an x, minus the 2's cancel, so I'm left with the 1. Okay, that one was kind of clutch. That's a good problem to end on. That was kind of hard. Put this on the test because we know how to do it. Hey, I have no comment. Okay. Whew. That was a long stream, bro. I started at what, like 8? Well, it wasn't too long. It was like a little over an hour. But these are some good questions. What I'll do, since I had like some technical difficulties at the beginning, I'm gonna just scroll through the first part of it. So if you want to like pause it and screenshot it, um, I'll do that. Yeah. All right. So there's 1, 2, and 3. If you need it, here's 4 and 5. I may do number 8 again before I go to sleep. I don't know. That one was, to me, that was the hardest one. But there's 4 and 5. Here's 6, 7, and then the number 8 that I am not sure about. Cause it's like I got an answer, but if I'm taking the test, I would go B, but I would try to like simplify just to make sure. Ooh, wait a second. Yo, hold up. Where did I get these problems? Mystery source. Mystery source. Um okay. With the answers. Um so about the College Board, I signed it, but I realized that the questions that I made, I couldn't turn it into a PDF. So I did come up with a whole new set of questions. But here's what I'll do. Before I get off, I'll actually assign it so that y'all can see it that way. That's what I'll do. But okay, but first, before I do that though, before I get off, I just now found a potential strategy for my answer for number 8. What I'm gonna try to do is, and I thought about this initially, but for some reason I didn't think it would work. I'm gonna try to write my one fraction as 2 separate fractions. My first fraction is gonna be a 1 over secant squared, which is a cosine squared. So hold up, let me see something right quick. Okay, so I'm gonna write each term in the numerator individually over my denominator. So let's see if this will work. This will be 1 over x secant squared of xy minus my other term in my numerator, which is y secant squared of xy, all over that same denominator, x secant squared of xy. Because look, now on that second fraction, something cancels. I don't know. Let's see. I think I might have cooked. Because 1 over x, well, really 1 over secant squared is, what do we say? Cosine squared. And then that x is still on bottom. So this would be cosine squared of xy all over x minus, on this second fraction, my secant squares cancel out. So that'll just be what? Y over x. Okay, wait. I have common denominators. I can subtract these and turn it into one big fraction all over x. There are answer choices with just an x on bottom. Cosine squared of xy minus y. Is that an answer choice? It is. I see it. I got nervous. It took me a while to see it. Okay. I heard in the chat somebody said that GPT said it was E. GPT was right. That was clutch. That was clutch. So it's not B. I got that one wrong initially. It's E. It's always the algebra, bro. I swear. Okay, I enjoyed that challenge. That was nice. All right, cool. Okay, so there's 8. Here's number 9. This one, number 9 is easy. It's just different. Meaning, like, you don't see these types of problems every day, I guess I should say. But that was just like a chain rule with a graph. Number 10, inverse function. Number 11, inverse trig derivative. Screenshot these if you need them. Number 12, implicit. Nothing crazy about that one. Actually, I wouldn't say it's crazy, but we did have to factor like to get my answer choice. Number 13, pretty basic chain rule. Number 14, what was this one? Chain rule with a table. Nothing too crazy. Number 15 is definitely not crazy. Low key, just flashcards. 16. People are gonna think it's crazy because they see arctan and cosine in the same like breath, and then they're gonna panic. But if you know your flashcards, this one is not bad. Just remember chain rule. Number 17, inverse derivative from a table. This one is hard because the function that you need to evaluate, they don't give you information about. So you have to use the fact that f and g are inverses. What? Oh. Okay, so that was 17. And then 18. This one, yeah, 18 was like the second hardest one in my opinion. One, because it wasn't a dy dx situation, it was a dy du situation. And so many people, myself included, when you see x squared, you just think 2x. But in this one, you had to remember that it was with respect to u. So you had to multiply by dx du. And then it was also hard because they don't give you x, they give you u equals. So what I did was I took that equation and solved for x first so that I can get dx du. That one was kind of tricky. Can I go over 18 again? Yeah, so basically, I mean, screenshot it, but I'll talk about it. Dy du is just the derivative of my y equals function. But whenever you see x, treat x like a OG, basically, because I'm deriving with respect to u. So the derivative of x squared is not just 2x in this case. It's 2x times the derivative of x with respect to u, which is this piece right here. Same thing on my other term. So yeah. Okay. All right. I'm about to go eat and then go to bed and then make some more versions of the tests. But all right, keep studying. You're gonna pass, bro. Lock in. Let me know if you have questions. And